actually tied to an extra credit problem on your exam. So pay attention if you want to pay attention to this part. We're going to figure out the theoretical probability of winning, not the experimental probability, because as Randall already said, and as Michelle already said, and I think as Carrie emphasized, we didn't see enough trials to see the true pattern show up. We'd have to play a few thousand more times because it's so damn close. And on your exam, the Excel spreadsheet that comes along with your exam, not Usain Bolt, but the other one, you actually are going to hold the F9 button down something like 15,000 times. And when I say that, I mean put a stapler on it, walk away, get something to eat, and come back. But every time it plays, it's going to play just like you did. I made a spreadsheet that plays craps. And it's going to be keeping track of the wins and the losses as you hold down the F9 button, which means go watch a movie, come back, and let it play 30,000 times. And then that's a lot, right? 340 is enough, but it's a lot, but not enough. So what you have to do is what's going to happen over an infinite number of trials. So let's talk again about how you win at craps, yes? Let's talk again about how you win at craps. I do want to talk a little bit about that last couple questions on your exam to make sure that you guys don't curse me any more than you already do over the weekend. Probability of winning, theoretical. Theoretical. So this is assuming an infinite number of trials. This is also what the actuaries are going to have to play with. The actuaries have to know this, because they have to know how much to make the payoffs in order to keep the people keep playing and betting and losing their money. So describe to me how you win again, in words. Describe to me how you win again. Either get a roll of 7, or roll an 11 first, right? That's one way of winning.
Or meet your point roll.
Or meet your point before rolling a 7, yes? Or meet your point before 7. So there's 3 ways to win. What we have to do is measure each of those 3 ways. 2 of the 3 are very, very straightforward. The third one's definitely tricky, and it's where the genius of craps. Whoever invented this game is purely a genius, because it's so convoluted. And, well, you'll have to see it. It makes me happy. Okay, so what is the chance? What's the chance of rolling a 7? You figured it out last time.
1 in 12?
Close. But it's better.
Oh, no, it is.
Close. How many when you throw a pair of dice, how many outcomes are there?
6.
Careful! That's 1 die. Pair of dice. 36. Remember your last project? Throw a pair of dice, list all the outcomes. There were 36 of them. 6 times 6. I'm hearing some people whispering at 6 times 6. 36 outcomes. How many are 7s? 6 of them. 1 and 6, 6 and 1, 2 and 5, 5 and 2, 3 and 4, 4 and 3. You counted them last time. Right? It's the most common outcome. That's reason number 1 why craps is brilliant. Make the most common outcome good for the player. Boom, right? No worry that it comes back and bites you in the butt later. Right now, make it good on the first roll. On the first roll, it works for you. So, right away, you've got a 1, can I call it 1, 6? You know what? The hell, 6 and 36. We'll keep the 36 going. So right away, you've got at least that much chance of winning. That ain't bad. That ain't bad. You've got at least a win every 6 games on average over time. That's what that tells me. Over 36 games, I know I'm going to win on 7s, 6 of those 36 on average over time. And I'm only going to add to that, because what's the chance of rolling an 11?
2.
There's 2 of them, right? 5 and 6, 6 and 5. Hot damn! My odds just went up for winning. 2 and 36. So now I know, out of every 36 games, I'm going to win on 8 of those games on the first roll. Of course, the rest of you are looking at me very cynically like, yes, but you're going to not win on the other whatever's left, right? No. And I say, yeah, glass is half empty, people. But I can also win here, yes? Now here's where it gets interesting. Here's where it gets interesting. This calculation is extraordinarily tricky, and just try to follow along with the logic. The mathematics is going to be a little bit much, but just try to follow the logic. This is going to be broken down into 6 pieces. And the reason it's 6 pieces are there are 6 different points. You could roll a 4, 5, 6, 8, 9, or 10. Right? Does that make sense? And if you roll those, you haven't lost right away. You still have the potential to win if you roll those. Faith, go.
Isn't it easier to figure out how many times you're guaranteed to lose on the first roll?
It's actually, I'm going to have you do that on your exam for extra credit. If you so choose, it's no easier. Because you still have to account for all those ways. No, what Faith is describing is called the don't pass bet. When you bet against the roller, you still have to do the crunching. It's actually, I think it's one more crunch or one less crunch, but it's essentially the same. I love what you're saying, makes perfect sense, except for the fact that the way this is set up, you can't get around it. What you said is, you take a 243, right? It will come in wicked handy in 243, because I don't use convoluted distributions like this very often. But Travis is worth studying, because it's just that much fun. Okay, so, in order to meet your point, let's go through 1 point at a time, yes? 1 point at a time. The smallest point you could get, the smallest point you can get is 4, correct?
Yeah.
What's the chance of rolling a 4?
4 out of 36?
3 out of 36.
3 out of 36.
Three.
2 and 2, 1 and 3, 3 and 1. There's only 3 ways to roll a 4.
Yeah, right.
Okay, so watch this. It's 3 out of 36, but that's just the chance of rolling a 4 on the first roll. Then you've got to roll it again before what happens.
That's what it's 7.
So now, after you roll a 4, so I'm gonna put 4. Can I put 4 in quotes up here? That way you know what we're doing. We're doing 4 right now. Now you've got to roll a 4 again, but all you care about is either getting your 4 or getting a 7, because that's the only numbers that mean anything, correct?
Right.
Well, there's 3 ways to get a 4, so you're still interested in the success of getting those 3 ways. So you still have only 3 options to win. You have to roll either a 1 and 3, 3 and 1, or a 2 and 2. But now your denominator actually shrinks, because all you care about are the 6 sevens and the 3 4s, which means the chance of hitting that 4 again between a 4 and a 7 is now 3 and 9. You know, how many of you guys had point rounds that went like 5 and 6 and 7 rolls?
Yeah.
Yeah? Did you even care about, did you keep track numerically of what roll you got when it wasn't your point or a 7? No, you flushed it away. It's almost like you didn't even roll that round. It didn't count. It's a do-over. This measures the do-over. It says on that second roll, you've got a 3 in 9 chance of hitting your 4 and not the 7. It ignores everything else. The snake eyes, the 11, the 12. Everything else it ignores except for your point and the 7. This is not easy, FYI. This is not an easy thing to kind of process. So if it doesn't make crystal clear sense, don't worry. If those of you taking 243 will attack stuff like it, but just realize why it's only 3 9s now. You have to hit the 4, which happens 3 ways, out of those 3 ways plus the 6 sevens. That's all that matters are those 9 outcomes. The 6 sevens you lose, the 3 4s you win. That's your new sample space. Does that make sense, Faith? Okay, and if it doesn't make sense, guys, it's okay. It's okay. It's not crucial to get that 100% right now. Let it kind of mull over in your mind. Now let's do 5, 6, 8, 9, and 10. Let's do each of the points in the same way. This is still positive, isn't it? This is still a plus. So you're adding to your probability. This is a good thing for us. Yes, Carrie?
Why is there not parentheses around the 3 over 36?
Oh, because you don't have to. It's in order of operations. We'll do this before we add it. We can put it if it makes you feel better.
No, it's okay.
We can. That doesn't change anything.
Okay.
It's totally fine.
It makes me feel better.
Okay, well then we'll do it. We'll do this too. Yeah. Let's do it for all of them. Now let's do the 5s. Let's do the 5s. And the 6s and the 7s, and not the 7s. The 4, 5, 6, 8, 9, 10. Those are the points that you could have. Okay? All right? What's the chance? What's the chance of hitting 5? 4 and 36, yes? It's 4 and 36. 5 is a little more likely than a 4. Now, once you've hit a 5, which happens that often, you have to hit the 5 again before hitting the 7. So you still only have 4 successes that you want. It's 4 out of 10, because there are 4 5s and still 6 7s, so it's 4 out of 10. That went up too. You have to realize, there's always going to, maybe this will make it easier. Does that make it any easier? Seeing that? Okay. Because there's always going to be the 6 7s in the denominator.
Gotcha.
The other piece of the denominator is also the successes. Probability is your successes over your total. And your total is part success, part failure. So you have to keep track of that success and failure as you go. Fair? So this is going to be 3 9ths, 4 10ths. Good? So let's keep track now of the 6s. See if you guys can see the pattern here. It's a beautiful pattern. Okay? I heard somebody utter it. 5 ways to get a 6. So it's 5 out of 36.
5 out of 11.
It's 5 out of 11, isn't it? because you have to hit your 6 again, which happens 5 ways, but there are the 5 6s and also the damn 6 7s. So there's 11 total. So do you guys like this better, the 5 plus 6? Is that better? To have it like that?
It looks cooler when you actually see 3 over 9, 4 over 10.
It's pretty slick. It's pretty slick. And what's cool about the pattern is it now repeats for the next 3. Watch this. Watch this. Because there are 3 more points, yes?
Yes.
And be happy. I know it's math and it sucks, but be happy. Because every time we add a fraction on, that makes our chance of winning go up. We're not adding negative numbers, are we? We're adding positive numbers. That's making it go higher. Hell yeah, us. Okay, you're not excited. That's okay. That's all right. Let's keep adding. There we go. Get it. Now let's go with 8. 8's the next point, yes?
Yes.
8's the next point. That's a hell of a quote, Mark.
4?
How many 8's are there?
5.
There's 5.
Shoot.
There's as many 8's as there are 6's. Remember the pattern from Wednesday? We had that. Thank you. It's a beautiful little pattern. The damn spreadsheet locked up, and then I couldn't show it to you. I was going to have it replicate for you, but it actually graphs a perfect 90-degree triangle. So there's an 8 in 36. Excuse me, 5 in 36 chance of rolling an 8. And then you've got to hit the 8 before a 7, which is 5 in 11. Because it's 5 plus, it's just like that. It's the same probability as rolling a 6. 6 and 8 have the same probability, which means they have the same chance of winning, if you get that as a point. It's almost like you can think of craps not as numbers on the dice, but just symbols on the dice. If you get a certain combination of symbols, you win. It just so happens that they are numbers, so we have to think about that numerically. Okay, what's 9 going to look just like?
5.
Absolutely, friends! You guys ready for Vegas already? 9's going to look just like 5. So it'll be 4 and 36, because there are only 4 9's. And then 4 out of 10, yes?
Yep.
There you go. And there's one last one. There's one last one. We got to deal with the 10's. Yep, you got it. 10's. Oh, this is hell of fun. Anybody wonder why you're multiplying and not adding? That's a 243 point. I swear to God, it's a big chunk of 243 is why you're multiplying. I'll give you the 5-second introduction. When you're saying stuff in English, if you say the word or, you add. If you say the word and, you multiply in probability. So in other words, when you're talking about how to win, you either roll a 7, or you roll 11, or you match your point. So what that means is you either roll a 4, and then roll a 4 again. Or roll a 5, and then roll a 5 again. Or, Haley's head's about to pause, I want to stop.
No, it's okay.
But that's how I teach my 243 students when to multiply and when to add. Say it out loud. When you say it out loud, if you hear yourself saying the word or, you multiply. Because or gives you options. You can win this way, or that way, or that way. Well, that's a good thing, because you're adding to your probabilities. The ands make it harder, because they make the probabilities go down. When you take 3/36 and multiply it by a fraction, it actually goes down overall. It's still positive, but the whole thing gets smaller because you're multiplying it by a fraction. Does that make sense?
So and is multiplied.
And is multiplied. Yes, ma'am. Now, that's different, I know, than in like, I will take an apple and an orange. You add those, like in the grocery store. But in probability, or means to add, and means to multiply. And that's a big chunk of what 243 is about, is knowing when to do what. That's why verbalizing helps. So, here we go. 3 and 36 times 3 and 9, right? Yep. All we got to do now is add all that up, and we got ourselves a solution. Let's do it. Let's do it. And I said we'll do it together. I was not lying to you. I try not to. Frequently. I usually do it unintentionally. Can I erase this up here? Is this okay? I just did it without waiting for your response. Such a bastard. All right, here we go. Can we see that? We can't. Let's zoom in a little bit. All right. Let's start and stop it again.